Hello everyone, welcome to our pre-calculus pre-recording video. This is for the discussion on practice quiz paper 4. So already you have the paper in this and couple of maths I think you already solved, or maybe all the maths you already solved. So you can match your answer here, but if you haven't solved the math, please first do the math, then watch the recording or look at the solutions. That is better, or else actually this is less efficient. I mean, if you first look at the answers, no good. So first you solve the math, then you can have a look, uh, and yeah, with the answer paper, with the recording, etc., etc. This is better. So hope you finished it. This is the answers of the first math: mean, median, and mode, and quartile related maths. So first question is sort the data from least to greatest and find their range. That means we have to arrange it from the lowest value to the highest value this way. So we can see that from all these numbers, 13 is the lowest value. So first we write 13. Then we have the number 14. So we write it. Then we move on to 16 and 18 and 21. Then if we arrange the data, it becomes like this. Now what is the range of the data? Range of the data is the highest minus the lowest. So highest number is 21, lowest is 13. So range will be 21 minus 13 equals to 8. Mean is what? So for finding the mean, what we will have to do is we will have to add all the numbers. That means 13 plus 13 plus 13 plus 13, then plus 14, and all the numbers, divide it by number of numbers. So how many number we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we will divide it by 9, then we will get the 135 divided by 9 equals to 15. This is the mean. What is the median? So median is the middle number of the arranged data. So we can see that total we have 9 data. That means 4 will be in this side and 4 will be in the other side. Middle number is 14. This is the median. What is the mode here? Mode is the maximum occurring data in the data sets, or the number that comes the most of the time. That is mode. So in this data set we have 13 here. 13 is the mode. Now last question here is find the interquartile range from the data. Interquartile range is quartile 3 minus quartile 1. Quartile 3 minus quartile 1. So how do we find out? Here we actually have written quartile 1, quartile 2 and quartile 3. What are the values? How do we find them? Quartile finding formula is I into n plus 1 divided by 4. For example, if we want to find out quartile 3, then I equals to 3. N equals to total. How many numbers we have here? We have here total 9 numbers. Then plus 1 divided by 4. This is 10. 30 divided by 4 means 7.5. So it is 7.5. Now be careful. Be careful here. Don't take it as a quartile 3. This is not quartile 3. This is actually giving us the number which one will be quartile 3. That means quartile 3 is 7.7 and half number. In other words, after 7th number, in between 7 and 8 number, we will have the quartile 3. So it means that between 7 and 8, 7.5 means between 7 and 8, whatever the number we have in our data, that will be our quartile 3. So we have 1, 2, 3, 4, 5, 6, 7. So this is 7 number data. Then 8 number data is 18. So 16 and 18 is here. What is the in between number or middle number of 16 and 18? You find it like 16 plus 18 divided by 2. Or actually you can see 17 is in between. So 17 is the answer here. For finding, let's say if you want to find out quartile 1, then actually you put 1 here, 1 here. So 1, then 9 plus 1, 10. 10 into 1 means 10. 10 divided by 4, that means 2.2. Now this is kind of tricky. 2 is 1, 2. So this is the second data. This is the third data. So 2.5 will come here if you put 1 and 9 here. Now 2.5 means in between 13 and 13. So what is the number in between 13 and 13 or in the middle of 13 and 13? Basically we can do it in this way. 13 plus 13 divided by 2, and answer is 13 again. Okay, so that's why answer is 13. Basically, if you go for suppose if you say that in between 2 and 2, what is the number? Answer is 2. This is the fun here, funny trick here, because they are the same number. That is the reason. So then we subtract from the quartile 3 to quartile 1, then we get the interquartile range. This is about which one is sample, which one is population. So population is in the left and sample is in the right. We have it like this. And what is the differences between? Discuss quantitative and qualitative, and discuss about the discrete and continuous variable. Quantitative means the variable that we can represent by quantity. Qualitative means the variables or the thing that we cannot represent by the number. We will have to talk about something else, like the quality of some people, quality of products, like that. Okay. With a discrete and continuous variable. Discrete means like separate numbers. This is called discrete. Continuous means the number or the thing that flows without any interval, without any gap. So that is continuous. Okay. This is the answers. Population is in the left, sample is in the right of the picture. Quantitative variable means variables that yields numerical information or measurement. These are the example. Qualitative means the variables that yields non-numerical, because it is quality. That's why sex, marital status, eye color, etc. Discrete variable means variables obtained as a result of counting. That is counting 1, 2, 3, 4. That is called counting. Counting number means 1, 2, 3, 4. That is counting numbers. Continuous variable means if we can measure something with arbitrary accuracy, that is called continuous variable. Let's say I have a pen. What is the length of this pen? So I can say that, let's say just approximately this is 1, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 centimeter. Then or 6.5 centimeter. Let's say I say 6.5 centimeter. Now, if anybody have some better scale, measuring scale, then they will say, hey, this is not 5.5, 6.5. This is actually 6.55. Suppose 5.5. So he goes one more decimal point. Then someone comes with more sophisticated devices. Then he can say that this is not 5.5 exactly. This is 5.554. So there is another decimal he finds out for the length. I can give you this example with better explanation if we look at something which in relation to something that you already know, and that is, suppose if I want to measure what is the weight of this mobile phone. So if you go to a grocery shop, they have like this kind of balance. So they put one side kg, half kg, 1 kg. So you give them, they will say this is approximately 1/4 kg or 2.5 250 grams. Then if I put it in some electronic balance that supermarket uses, or even in some grocery shop also they uses now this electronic balance, then they will say, oh, this is actually 240 point this decimal number also they will say. So that means the weight of this one actually depends on what measurement or what measuring tools we are using. We can go for arbitrary accuracy, we can go for more accurate and more accurate and more accurate answers for this one's weight. Same thing goes with length. Suppose if you measure your length at your home, say you ask your sister or brother, okay, let's find out my length, and you have some tape measurement, then she measures it, and then she will say that, oh, this is the approximately, she will tell you the answer, not the very precise value. But if you go for some interview in like defense and they measure your height, they actually go for the more precision, more decimal places. I think you got the point. So some of the things we can measure with better and better accuracy, better and better accuracy. This is actually, then it is a continuous variable because it can go that way. Another example is time. Time is also, temperature is also continuous variable. If you let something cool down, suppose you boil a cup of water, cup of tea. Cup of tea is not a good idea. Less, a cup of tea is cooling, and so cup of tea is cooling. So when it starts cooling, let's say the temperature, initial temperature is 80 degrees Celsius. So from 80, all of a sudden it will not come to 40. It will continuously drop. 80, then 89, 78, 77, 76, 75, 74, 73, 72, 71, 70, 69. Then this way continuously. You see, and in between decimal also, of course, 79.5, 79.4, 79.3, continuously it will come down. That's why these are called continuous variable. We are just taking a little time here so that this concepts enters in your mind for a long time. That's the reason, no other reason actually. That's why we're giving all these examples. I hope you already, actually it will take just a few while to just read it and keep the statement in mind. But remember, human being understands a thing by a story and then by example. The more example you can save in your mind, the better you will understand the story. Human beings understands by the story. Anyway, so we have these questions. This is like extract the data from here. That means comedy is how many people. We can say comedy is 4, action is 5, romance is 6, and drama is 1, sci-fi is 4. We can see, interestingly, many people are watching romance movie. I'm not sure why. So from the following pie diagram, find the how many grams of vegetables eaten if the total amount of food consumed is 800 grams. So vegetable is this green color. This is light green actually. So 14%. So that means 100% equals to 800 and 14% equals to what? Then we can find out the solution. And these are stem and leaf. So this is 44, 46, 47, 49. Then for 50, no numbers, 63, 64, 68, 68, 66, 68, 68. So see, 68 comes 2 times, and actually no other numbers are repeating here. That means 68 is the mode. Suppose if someone asks you what is the mode in this stem and leaf diagram. Stem and leaf means this is the stem, like a tree, like a tree. You have like some stem of a tree, some stem of a tree. Let's draw a tree. So then you have some tree, these are the leaves, and these are actually analogous, actually, that is why I'm drawing it here. So this 4 is the stem, 4 is here, then you have leaves like 4, 6, 7 and 9. That is the reason 44, 46, 47, 49. Okay, this is stem and leaf diagram. This is the answer. Actually, we have the answer, 12 grams. So this comes like 100 equals to 100 equals to 800. 100 equals to 800 grams. Then 14 equals to what? This way you can do it. Okay, like this way we get this 112 grams. Like 100% equals to 100% equals to 800 grams over 800 grams. Then 14% equals to what? Then 14% equals to, it will be 800 into 14, 800 into 14 divided by 100 equals to 112 grams. This is how we solve this math. This is how we solve this math. And for this maths, as we said, if we just giving it here, it's not necessary, by the way, not necessary. Suppose from this data, what is happening here? From this data, oh, is it necessary? It's not necessary. Let's not write it. We said that mode is this. Oh, 72 also comes 2 times. That's interesting. Yeah, 72 also comes 2 times. So the 68, is there any number repeating? Oh my god. Yeah. So mode is 68 and 72. See, for the in maths, this is impossible to do some partiality. Suppose I like 70, 60, 68, and then if I say that, okay, 68 is the mode, so partially I like it, that's why. But then automatically I notice 78, and then my, or you will notice 72, and you will be like, sir, why 72 is not the mode? Because this is repeating 2 times, this is also repeating 2 times. So what is the logic? Then I am in a very, very huge trouble, because I have no other logic to explain why I like it. Okay? Do you want to hear a joke about the partiality? So let me tell you this. I know this is in the discussion, but still this is, look at this. So in a job interview, 2 candidates, they are sitting back to back, and the interviewer actually likes one of the guy because he is his cousin, and then the interviewer is asking all the very, very easy questions to his cousin, and very difficult questions to the other guy, because he will take just only one candidate from the one employee. He will hire just only one of them. And then the other guy actually realized all these things, and he's like, no, this is not fair. You are asking all the easy questions to this guy, but you are asking difficult questions to me. I want another chance. You should give me another chance. Then the interviewer thought a while and said, okay, cousin. First he's asking his cousin, not by saying the cousin. He's asking, okay, to his cousin, he's asking this question. Okay, how many people died during the liberation war of Bangladesh? And then his cousin says, okay, this number is 30 lakh. 30 lakhs means 3 million. Yeah, 3 million. So, and then he asked the other, the one he don't like, he asked, okay, you tell me now the name of these people who died in liberation war. Do you understand? Do you understand? He asked, he asked the other guy to tell the name of 3 million people. Oh my god. Oh my god. So in math, this is impossible to do the partiality because the answer is so obvious. The answer is this is impossible. In math do not allow that. Math is unbiased totally. All right, so now for this question we have data set B. We will have to find out the variance and standard deviation and then analyze this data set. First, you will have to extract the data. So it will be 14, then 15, 15, 15, 16, 16, 16, then 17. That means 16 comes 3 times, 15 comes 3 times, 14 and 17 comes once and once only. This is called dot plot because we put some dot here. That's why it is called dot plot. So first of all, we take the number, then this is the mean. To find out the mean, we just take the average of everything and then we find out the variance. For finding the variance, we use the variance formula here, which is summation of xi minus mu whole square divided by, this is sample actually, sample data, so n minus 1 for the sample, n minus 1. Like 14 minus 15.5 whole square, then 15 minus 15.5 whole square, this way is 16 minus 16.5 whole square, 17 minus 17.5 whole square divided by n minus 1. So n means 1, 2, 3, 4, 5, 6, 7, 8. That means 8 minus 1. Then we should get these answer. Let me check it again. Let me show it also here. Okay. Since we have this, so it will be like what? It will be like, let's give a 2 bracket. So 14 minus 15.5, then whole square, then plus. See, we have 1 to 3 15s. So instead of writing all of them again and again, we can just write 15 minus 15.5 whole square, then plus 16 minus 15.5 whole square. Oh, we can give here 3. Then we will not have to write it again and again because 3 times it comes. That's why. Then plus 17 minus 15.5 whole square, 15.5, then whole squared, then divided by, then we give a bracket, then divided by n minus 1. So n minus 1, let's write it in full length. 1, 2, 3, 4, 5, 6, 7, 8. That means 8 minus 1. That means 8 minus 1. So this equals to, I think we should get this number. So this is 14 minus 15.5, which means 1.5, negative 1.5, but it will become plus because there is a square. So let's square it. Can I do it, the whole thing in the calculator? Yeah, we can do it. Let me try. So 14 minus 15.5 whole square, then plus, it will work. Then bracket 15 minus 15.5 whole square, then then 15 minus, okay, then 3 into 16. So let's put 3 plus 3 into 16 minus 15.5 whole square plus 17 minus 15.5 whole square equal to divided by 7. This is 0.857142.857. Oh my god, that's interesting number. 857.142.857. I wish we could go more to see the pattern. So yeah, this is the answer coming. 8.0.857. Then if you want more, 1428142.857. You do not have to write all the numbers. Here we kept only up until 3 decimal. 3 decimal is fine. 2 decimal is also fine. But 2 decimal is, since the number is too small, that's why if the trick is here, suppose some students sometimes gets confused like how many decimal you have to keep. If the number is too small, then I'm putting the computer to charge because it looks like only 25%. If the number is too small, then it is actually a requirement to write it more, to elongate it a bit, okay, to write it more. And if the number is too big, suppose you are writing 300,000. For a number 300,000, that decimal is less significant. Anyway, so how do we find out the standard deviation now? Is square root of variance. So variance is this. We can just square root this, then we get the variance. Now, what does it mean? It means that since the standard deviation for the data set for this data set, which is B, standard deviation is very small. This means that data set A is scattered, B is not scattered. Okay, this means that data distribution in A is much scattered than B. What is happening? Oh boy. Okay, so this is the decision that we can take from here. Of course, we can talk about, since the mean is also same, etc., etc. How many data we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 data. So which of the figure is skewed, symmetric, etc., etc., and why? This kind of questions here. As we can see, this is symmetric, this is right skewed, and this will be mean, this will be mode, this will be median, because because mean is in the, if it is right skewed, then the mean is in the right side. And so you see, this is kind of in some figure. Let me tell you this. Don't get confused. Although although we always put this red line in the middle, but in some extreme case, which you may not see in our exam or in our lesson here, but just for future reference, if you take the statistics in UG, in some cases actually I have seen that this red line or median line can actually come here, or it can move. Okay, median line can move little bit from here to here, from here to here. It can come close to that line. So just only, that's why sometimes you'll notice that I always, when I talk, we always talk about first this line and then this line. So these two line is actually very definite, very sure, and this line actually can, in some figure actually I have seen that we have seen that this line can actually move here and there. So that, just be flexible about that. Okay, be flexible about that. Of course, if we can identify which one is mode is always the highest line. Which one is mean is always in the right. If it is right skewed, mean is always in the left. If it is left skewed, and mean, median, mode all is same. All is same if it is symmetric. If it is symmetric. Although you can see that, you can say, sorry, this is in the left, this is, no, actually all of the lines are same. Suppose if mean is 5, median is also 5, mode is also 5 for this data. This is what it means. Okay. This is symmetric, this is also symmetric, this is bimodal data, so we have two mode, one here and one there. This is right is skewed, this is left is skewed. Okay, all the answers are written here once again for your help. Now this is the histogram given, and from this histogram actually first of all we can extract the data, like how many people got 4, 1 people, how many people got 5, 1 people, that means 4, then 5, then 6 will come 2 times, 6 comma 6, then 7, 7, 7, 7, 7, 7, like this. In this way we can extract the data like this. 6 comes how many times? 1 time. 7 comes how many times? 4 times. This is what? For histogram 2. 7 comes how many times? 4 times. 1, 2, 3, 4. 4 times 7 comes. Like this. 8 comes 3 times. 9 come 1 times. And 10 come 1 time. Mode is what? Mode for data A and B is 7. See, 7 is most repeated here. 7 is most repeated here. Okay, so for both cases, 7 is the mode. For figure A, this is symmetric, and figure B, right is skewed. Both mode is 7, mean is this and this, median is this and this. Since the number of sample is different, so not a good representative of data comparison. So we actually cannot compare this data. The reason is the number of sample is not same. The number of sample is not same. Here you have more sample, here you have less sample. So that's why we cannot compare it. Okay, we cannot compare these two data. They are not good representative of data. That is the reason. And this sentence is also a comparison. Suppose you can say that we cannot compare it. That is also a comparison. Because why? Because not a good sample. Sample is different. This line, these two words. Sample is different. The sample number of sample is different. So this is also your answer. It's not like you cannot answer it. You already answered it here. Because sample size is different. So you know that if sample size is different, then we cannot compare it. Okay. So this is one way to analyze it. Of course, still we can talk about this and that. Like we already said, which one is skewed, which one is not skewed. This kind of thing actually we can talk. Okay, but no deeper comparison. This is two authors letter count related problem. So we have here Devi and Mari, their letter count. This is like, what do you know? This is like, suppose you have some paper or you have some passage or paragraph. Some people have the tendency to write most of their words in very big word, and some people write always a small word. So this is like that kind of comparison. Okay, and modern computer people can use, suppose in a book there is no name. Who wrote this book? Nobody knows. From the past, people actually analyze this way to find out the unknown author, who is that author of the book, and they look at the pattern, writing style, writing pattern, number of letters in his passage, paragraph, or the whole writing, what type of letter he is using the most, what type of words he is using most, how many letters are there in his writing, most of the words. So this way, they actually can find out or narrow down who is this, who can be the unknown author here. This is actually a approved method or practiced method for finding unknown author. Okay, so this kind of math actually have some very strong application, especially to find out unknown people. And if you become very secret someone, then actually this is more. Anyway, let's ignore that. So this way we can actually use it for finding the unknown authors. Okay, so this is a good application of this and that. And then so this is the letter count and calculate for mean and etc. This and this. So first, whatever we do, first of all, we will have to extract the data, and that is 2, 3, 3, 4, 4, 4, 6, 6, 8, etc. Devi, this and that. We can find out this and that. And mean for Devi is what, median for Devi is what, mode for Devi is what. We can use this extracted data to find out all these answers. Okay, mean, median, mode. Then it appears that the median is always closest to the mode, while the mean tends to be farther out of the tail. Both the distribution shows is skewed in nature. How do we know? Because of the mean, median, mode's position. You know, if the mode is here, and suppose mean is in some one side, then this is skewed in the right side. If mode is here, mean is here, then it is skewed in the left side. So this way we can understand it. And also we can understand it by looking at the data. For example, mode for Devi is 3, mean is 2.7. So mean is 2.7, mode is 3. So 3 is here, 2.7 is here. That means it is in the left skewed. This is for Devi. Now you go to the picture. This is the Devi, and you can see that data is left skewed. This is the highest peak. This is the another peak. This is another peak. This is another peak. So if you just draw a data like this, so it will be something like this. So you see this line is left side is bigger. So this is left skewed. We can see that this is left skewed, and the other side for the other data also we can actually look at. This is Mari is 4.6, and this is the mean is 4.6, and the mode is 6. So the same thing. So this is same. Mean is 4.6. 4.6 is here. Let's say 4.6 is here. Then mode is 6. So 6 will be here. So 6. Mode is bigger. Mode is, you see, I am just looking at the relative position. So mean is here, mode is here. That means the data is like this. Because of that position. Or also simply you can say if mean is in the left side, then that is left skewed. Okay, that's very easy way to understand it. What is happening here? Why Davis is here? That's no need. Okay. So both of the data distributions show discreteness. Now you see what happened here. We actually compared it. We actually have written one line here which data is skewed. We did not say that the like how many numbers we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of sample is, oh boy, number of sample is same. My charge is too low. Sample is same, so actually this is fine to talk about the data distribution, but we cannot go any further because that's all about this. If you want, another way is if you want, you can write all these things here also before this line, but that's also somewhat redundant because that's written in the B number. Suppose sometimes in the analysis we use the digital value. We say that the mean of this figure is that, the mean of that figure is this. So there is a difference here. The median of this figure, this data is this, the median of this data is that. So there is a difference here, difference in between the mean and median. So from the data also we can differentiate. But since all the data we have in the B number, so we can directly compare it here. Like it appears that the median is this, mean is that, like this. Okay, distribution shows the skewed in nature, and what is skewed we can say that also left skewed. Both of them left is skewed. left skewed, skewed, left is skewed. Uh, we can say both of the data, they are left skewed. Okay. Now for the box plot, actually we have this is the math that you have. We have given one concept page here. In a box plot, this is just for concept. This is the whisker. This is the whisker. Okay. So the last value is the largest sample value, and this is the smallest sample value. So to find out the range, you subtract this minus this. Okay. And this is the box. This is the whisker. This is the box. This is the whisker. Length of the box, see, this is very important here. Length of the box is the interquartile range. So when you find out interquartile range in our question number 1, I think, yeah, in the question number 1, we have tried to find out the interquartile range. What does it mean? It means actually the length of the box. This, in the box and whiskers plot, what is the length of the box? That you will find out from the interquartile range. Why? The reason is the last part of this box is quartile 3, which is called upper quartile. This is quartile 3, and this is quartile 1, lower quartile. And the middle is here, middle half of the sample. Actually, half of the sample is here, and another half of the sample is here and here together. Meaning in this box and in this box together is 50% data, and only in this box we have another 50% of the data. So interquartile range means the length of the box. This is what we do. Okay, interquartile range is this. And median denote what? This, from the median, left side is half of the data, right side is another half of the data. Half means 50%, 50%. So if we say that, let's say if we ask that, if we tell you that 1, 2, 3, 4, 5. If I say that in this data distribution, suppose if I ask you this question, in this data distribution, 60%, let's say 30% data is, let's say 40% data is less than 6 or less than 6, or even 30% also I can say. If I say that 40% or 30% data is less than 6 in this data distribution, is it true? Look what I'm saying. 60%, 30% data is less than 6 in this data distribution. So is it possible? This is actually not possible, because we already know that this whole space is only 25%. Then how can this be 30 here, 30% of the data? 30% of the data will be in this box, in this box, in this box, of course. Okay, 30% data is here, somewhere here, 30%. Because this is 25% gap, this is 50% gap, this is 75% gap. So already we know that, right? Suppose if I ask you, this 10 is how many percentile, or how many percent data is 10, and then if I give you option, 10 is in the 75%, 10 is in the 80% data, 10 is in the 60% data, and then 10 is on the, let's say, we say 52% data. Okay. Now see, this is not like 100% accurate. Like we can we can find out this is approximately I'm asking. We can actually precisely find out what is that, what is this. But approximately, you see, this is, since this is 75%, then 10 is more than 75%. So only option is 60%, 80%. So only possible answer is this one. Only possible answer is there, maybe 60%. Okay. Yeah. Now say if I to make it more complicated or confused, if I write here 95%, then also you should say that it is 80% theta, because 95% will be somewhere here. This is too close. This is 75, so 80 will be more acceptable answer here. Not 95, because 95 will be somewhere here. The whole box is 100. The whole not box, the whole data set from here to here is 100. Box is 50%. Another 25 here, another 25 here. Okay. So this is my point is, this is always good to analyze it. What you read, what you understand. This is always good to try to analyze it. Okay. This helps actually. Now, let's say this is about something. Can we say that 1, 2, 3, 4, 5? 5 people. 1, 2, 3, 4, 5. 5 people are 1, 2, 3, 4, 5. Then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, just to make an absurd question, I'm trying to make some illogical question here. This is tough to make illogical question to some degree. Let's say we say that five people are better than 5 people. These 5 people in the let's say we say that the 5 people in the fourth quarter is better than the 5 people in the first quarter. Is it true? We do not know. We do not know. So we will have to say that no. That's this decision we cannot take from here. So this is a false statement. Okay. This way we can take the false statement, because first of all, we do not know if these are people. Maybe these are some bread. These are some apple. Maybe these are some potato. We do not know. So basically we cannot decide about that. So this is false. Okay. So this is some kind of hint, like what do you understand from this box and whiskers plot. Like this kind of maths also tells us, like when we analyze it, here what is mean, what is median, what is mode, what is quartile 1. So quartile 1 is here. This is the smallest value actually. This is 3. Quartile 1 is here, which is 7. Quartile 3 is here, which is 15. Then median is here, which is 13. Then highest value is here, which is 21, like this. And we have the answer here actually. So no worries. Median is 13, range is 21 minus 3, which is 18. And for the test 1, for the test 2, what is there? Quartile 1, median, quartile 2, median. And you can see quartile 1 is 6, quartile 1 is for the test 2, quartile 1 is 9. Did I write 9 here? Test 2, 9. Yeah, median is 12, 12. Median is 12, 12 for both of them. And test 2 is significantly better, as 75% of the students scored more than or equal to 9 in test 2, whereas for the first test, whereas for the test 1, that number is 6. That number is 6. This number is 6 here, then this number is 9. And most of the students scored. This is 75% of the data is this side. This is another 25%. You know that. That means 75% of the students, their score is 9 or more than 9 in the test 2. So this test is better. But here, the same thing, this 75% is now starts at 6. That means their score is low. Okay, this way you can decide about their score and this and that. And do I have anything else to say? It's fine. So that's all actually. With this we can finish our this revision video here, and very best of luck for the quiz 4. Hopefully you will be able to do very well in this quiz because of because you are working hard. Let's put it this way. Thank you all. Thank you very much for your all works and contributions. By the way, even if we send this, you see this solution, you see this working, still you will need to send your working in that file that you have seen in the homework button. So for that you will not have to do anything new. Let me make it clear. You will not have to do anything new. You are doing the, suppose suppose, see, I also, whenever I also do this rough work in my paper, even this maths also, if necessary, sometimes I do the rough work. You just send me the rough work picture. You will not have to do anything like new. You will not have to do it again and again for the fresh, because I understand that people have other things also do, other emergency and important things also to do. So basically, this is how we can maximize your time efficiency. Okay, and but if anybody wants to make it fresh and if you have time, that's also fine. That's also fine, no problem. In any case, thank you all. Thank you very much. Have a good day, everyone, and very best of luck for the quiz. Thank you, everyone, once again.